So now we will find the recurrence relation which is satisfied by Rn, where what is Rn? Rn is the number of regions that a plane is divided by n lines if no two lines are parallel and three lines are not concurrent. Find number of regions if 13 lines are drawn. Okay, so what is the question? We are having a plane. In this plane, I'm going to draw one line. So this one line divides the plane into two parts. So R1 will be equal to 2. What is R1? R1 means how many regions you will get when you draw one line. If I draw two lines, I'm going to get R2 is equal to, so let me draw two lines in the above figure now. When I draw two lines, I'm going to get four regions. So R2 is how much? Equal to 4. In general, what is n lines? For n lines, the number of regions that we are going to get is called as Rn. So R1 is equal to 2. And suppose I draw no line, suppose I draw zero lines. What will happen if I don't draw any line? Then the number of regions that I'm going to get is how much? The number of regions I'm going to get is how much? 1. So this R0 equal to 1 will become our what? Will become our initial condition of the recurrence relation. Now you observe that when you draw three lines, suppose I draw three lines. So when I draw three lines, how many regions I'm going to get? Remember, we are not supposed to draw parallel lines. So this is not allowed. You are not supposed to draw parallel lines. You're also not supposed to draw concurrent lines. Three lines should not be concurrent. Okay. So when I erase this line, now let me take three lines. The number of regions will be 1, 2, 3, 4, 5, 6, and 7. So R3 is how much? R3 is 7. Now we observe a relation between these numbers. So what you observe is at the nth stage, what will happen? At the nth stage, the number of regions at the nth stage will be how much? The number of regions at the n minus 1 stage. Look here, 4 is added with 2, and then here 7 has been obtained by adding 3. So the nth stage answer is nothing but the previous stage answer plus the number of stage. So this, if it's a third stage, you're going to add 3. If it is a second stage, this is stage 1, this is stage 2, this is stage 3. So if the stage is nth stage, then you're going to add what? Then you're going to add n. So this with R naught is equal to how much? What is the number of regions when there was no line? There was only one region. So this becomes a recurrence relation. Now we are going to solve this recurrence relation by using the iterative method. So what is the iterative method giving us? So I will write down the recurrence relation as it is again. Okay, so I will write down Rn is equal to how much? Rn minus 1 plus n, which is equal to, now I will substitute what is Rn minus 1. So what should I write instead of Rn minus 1? Rn minus 1 can be written as what? Rn minus 2 plus n minus 1. okay, because I'm using replacing what? Replacing n by n minus 1 in the recurrence relation or the original recurrence relation. So this is nothing but Rn minus 2 plus, I'm collecting these people together now, n minus 1 plus n. I will not simplify this, okay? Now what is Rn minus 2 equal to? Rn minus 2 is Rn minus 3 plus n minus 3 plus n minus 2 plus n. So this is the third stage, okay? So if this is the third stage, what will happen at the kth stage? At the kth stage, I will get what? I will get Rn minus k. Observe here, if there is a 3 here, then I'm sorry. This will be n minus 2, n minus 1. Okay. If there is a 3 here, then there is a one less person here. So if there's a k here, here you have what? Here you have a k minus 1. So what will the thing will come as n minus k minus 1 plus dot 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 plus n minus 2 plus n minus 1 plus n. Okay, so this will be the and this will be the situation at the kth stage, right? Now this is Rn equal to LHS was Rn, okay, and now I will put k equal to how much? I will put k equal to n because I want here to get R0. So when I put k equal to n, what will I get? I'll get Rn is equal to R0 plus n minus 1 because k is equal to n plus up to n minus 2, n minus 1 plus n. So this will be, now I'll simplify this. This n and this n will actually get cancelled and you'll just get what? You'll just get a 1. So what will be Rn equal to? Rn will be R0 plus the first term will just come to be 1. The second term n and n cancel and you'll get a 2 and so on till what? N minus 1 plus n. Right. Now this particular entire thing is nothing but sum of first natural numbers, and we know what is the sum of first natural numbers equal to. It is equal to n into n plus 1 upon 2. So this means that Rn will be how much? Rn will be R0. What is R0? R0 is our initial condition, which is 1 plus what? N into n plus 1 upon 2. And so this is actually the solution of the recurrence relation. What is the recurrence relation? The recurrence relation is Rn equal to Rn minus 1 plus n with the initial condition. How much? With the initial condition R0 equal to 1. So now you can simply put n equal to any value. So if I put n equal to 13, because we want to find the question originally was saying how many regions will you get when you draw what? When you draw 13 lines, okay, how many regions will be formed? So in that case your R13 will become how much? By this formula it is 1 into 13 multiplied by 14, 13 plus 1 divided by 2. So this becomes 1 plus 9, 1 plus 91, I suppose. Okay, just check. Okay, and that will give you 92. So I hope this answer is correct. Please check in your free time. So this is the way you will solve this recurrence relation and find the number of regions after drawing n non-parallel, non-concurrent line in a plane. Okay. Develop a recurrence relation to solve problem of Tower of Hanoi for n disks with 3 towers or pegs. So what is an? We will say an is number of moves needed to transfer disks from first tower to third tower. This is the first tower, this is the second tower, and this is the third tower. So we have here n-1 disks in the first tower. So what we will do, we fix the last nth disk to tower 1. Shift n-1 disks from tower 1 to tower 2 by an-1 moves. Shift last or the largest disk from tower 1 to tower 3 by 1 move. Then shift n-1 disks from tower 2 to tower 3 by again an-1 moves. Therefore, an, which is the total number of moves needed to shift all the n disks from the first tower to the third tower, is given by an-1 plus 1, the move from first to third, and last is again an-1. And how many number of moves are needed to shift one disk? To shift one disk, we need only one move. So we get the recurrence relation an is equal to 2an-1 plus 1 with the initial condition a1 equal to 1. So we can now solve this by iterative method. We have already solved this recurrence relation in the lecture of iterative method, and we have obtained that the solution of this recurrence relation comes out to be 2 raised to n minus 1. So this is the number of moves needed to shift n disks from first tower to the third tower by the Tower of Hanoi set of rules.